Solving systems by elimination. So we've done it with graphing and substitution. All right, graphing was just with your calculator. You found where the points intersected. Substitution, we had to solve for x equals or y equals, and then we plugged it back in. Now we're going to do something called elimination. And this one, in my opinion, is more fun, but it's like a little harder. But when you can get it right, it's like, it pleases the brain. All right, so we have all these steps. We're just going to do them, and then we can go back and read them. Okay, so we're going to solve this using elimination. So essentially what we want to do is we want to find, I'll put this here. We want to find a positive and negative coefficient and variable. Or maybe I could say a matching. Okay, what does this mean? So this has already done it for us, luckily. So see this negative 4y and positive 4y? This is matching but opposite, right? Like one is negative and one is positive, and it's with the same variable. It's both with y. So this is what we want, and this is how we can do elimination. So sometimes it's given to us like this. Sometimes we have to do something to get it to that, right? Sort of like when we were doing substitution, like sometimes I gave you an equation that was already x equals and y equals, and sometimes you had to play around with it to get it yourself. So obviously the problems in the beginning of the lesson, they're going to already be done for you, and then later on you're going to have to do it yourself. Okay, so the whole point is once it's opposite, you're allowed to add them together. So I'm just going to have this parentheses, and we're going to add them together. So we do 3x plus 5x is 8x. Negative 4y plus 4y is 0. And then 10 plus 6 is 16. So the reason why we want them to be matching, the positive and negative, is so that this goes away, right? That's the whole point. It's like by design. It's not just a coincidence. And so once that happens, we're stuck with just one equation. And remember, if you have one variable, you only need one equation, right? If we have two variables, we need two equations. So we can solve for x, divide both sides by 8, we get x equals 2. And then now we can plug it back into our original either one, and we can figure out y. So this is a very similar step to what we've done before. So we're going to do 3, 2, minus 4y equals 10, right? Just going to pop that in there. And then 6 minus 4y equals 10. Negative 4y equals 4, so we get y equals negative 1. So our final answer is going to be 2 comma negative 1. Okay, so this was elimination, but just to prove that it works, we're going to put it in the calculator. Well, you could prove it two ways. You could plug it back in, or you could put it in the calculator, so I'll do both. So we have, actually no, I don't want to rearrange this to y equals. So we're just going to plug it back in. We're going to check. So, check. So we have 3 times 2 minus 4 times negative 1 equals 10. So we have 6 minus negative 4 equals 10, which is 10 equals 10. So we know it works for the first equation, and then we're going to check for the second equation. So we have 5 times 2 plus 4 times negative 1 equals 6. 10 minus 4 equals 6. That works, right? So this is how I know I got it right. So if this was a test, and I was like, I want to make sure I turn this in correctly, you can check and know. Or you could graph it in your calculator. But I didn't want to graph it because I didn't want to make this into y-intercept form. I was too lazy. I didn't want to rewrite it like y equals. So either one works. Okay, so after we've done all this, let's go back and read the instructions, right? So step 1, make sure all the variables and the equal sign are lined up. They did this for us. Decide which coefficients you want to cancel out. To cancel out, they must be opposites. You might have to multiply the equations first. So this one was already opposites. So step 1 and step 2 are already done for us. Step 3, add the two equations and solve the new equation, right? So we added it and solved for x. Step 4, take your answer and plug it back in. That's how we found y. Step 5, we write it as a coordinate pair. And then step 6, check. Right? Step 6, check. Okay, so let's do one more together, and then you should try 3 on your own. Okay, so actually, why don't you do 2, and then I'll do 3. All right, so try 2 on your own. Pause the video, come back. All right, so for this one, we have our opposite terms, but it's over here in the x, so that's okay. It doesn't matter if it's x or y, just one of them needs to be opposite and matching, right? So we're going to add them. This turns into 0. We get negative 4y equals 0. And this seems tricky at first, but if you just say it out loud, it makes a little more sense, right? Negative 4 times y equals 0. Okay, so y equals 0. Or you could divide both sides by negative 4. And you get y equals 0 over negative 4. 0 over anything aside from 0 is 0. So you have y equals 0. And then we just plug it back in. So we have 2x minus 0 equals 12. So we get x equals 6. So our final answer is 6, 0. All right. I'm going to skip around a little. I'll do 4, and then you guys can do 3 and 5. Okay, so with 4, we can see that none of them are matching right off the bat. They are lined up, right? So they did step 1 for us, right? We have our x's and our y's lined up and our constants lined up, but none of them are equal. So we can sometimes multiply by both equations. Like I could have multiplied this one by a 3 and this one by a 2 so that these match up. But I want to do the least amount of work possible. So I'm just going to take this whole one and multiply it by negative 2 so that I can get these to eventually match up. So we have 4x minus 3y equals 8. And then we have negative 4x, be careful with your negatives, plus 4y equals 0. And now I can parentheses it and add it. And this becomes 0. This becomes just 1y. And this becomes 8. So I didn't have to do any more. They already told me y was 8. And then I go back and plug it in. So I'm going to put it in the top equation. 4x minus 3 times 8 equals 8. 4x minus 24 equals 8. We're going to add 24 to both sides. 4x equals 32, which gives us x equals 8. So this one, they were both 8. Our answer is 8, 8. And just to be sure, you can check. You could check with the second equation, right? You could do 2 times 8 minus 2 times 8 equals 0. Well, that's pretty clear, right? 16 minus 16 is 0. So, right, it seems sort of weird because they're the same number. I just went back and checked. All right, so pause the video, try 3 and 5. 5 is probably the trickiest one, but I believe in you. Okay, so for this one, there's a few options. I'll write this here in a different color. Few options. Right, these are notes, so if this doesn't help you, if this isn't helpful for you, don't write it down. If it is, so that you can look back, write it down, right? So you can either multiply equation 1 by 6, or you can multiply either by negative 1, right? So if I multiplied this top one by 6, then the x's would cancel. If I multiplied either of them by negative 1, then the y's would cancel. So I'm going to do the 6 because for me, my brain likes that better. So if I multiply this by 6, then I get 6x plus 12y equals 4. And then this one, I'm going to keep the same. We add it. So we have 0, 14y equals 6. No, that's wrong. Oh, I didn't multiply that. So 24. Right, so make sure you're multiplying across everything. So 14y equals 14, which means that y equals 1. And then we plug it back in. So we have, I'm going to do this beginning one before I transformed it, because it's just, the numbers are smaller. It makes it easier. X plus 2 times 1 equals 4. So x plus 2 equals 4. X equals 2, so it's 2, 1. And if you had done the -1, you should have gotten the same answer. So either should work. It's just whatever makes your brain happier. And then for 5, this one is the hardest one. This one we've had to multiply both. So I would say the easiest thing you could do, well, the one with the least numbers is 2 and 3, so that they would be 18. So right, this one, if I multiply by 2, and this one by -3, then the x's would cancel. But you could do a lot of different numbers. You can choose the other number. Like I could do 6 and 9, and then they would both be 54. So there's lots of options, but sometimes you just want to pick the smaller one. So I'll do this one, and then I'll do another one that might have been a little more obvious. So we have 18x plus 2y equals 78. And then -18x minus 39y equals 27. We add them. We get -37y equals, what is that? 105? 78 plus 27. 105 divided by, oh, that's not right. Where did I go wrong? Forgot to multiply the 2y. This is a 4. This is a 35. So 3. So y equals -3. And we plug it back in. 9x minus 6 equals 39. Skipping a step. 9x equals 45. X equals 5. So it should be 5, -3. I'm going to do another one that's maybe a little easier to see, because the 2 and 3 is sort of tricky. Like you might not have noticed that the 18 was the smallest it could be. Something that's easy is just choosing the opposite number. So I could have done 9x plus 2y equals 39 times 13. And then I could have done 6x plus 13y minus 9. And then this one I would have just done -2. Right, so I pretty much just chose the opposite of this one. Right, I did the 13 over here and the -2 over there. So let's see if I cannot mess this one up. So big numbers now. 117x plus 26y equals 507. And then I get -12x minus 26y. Oh, that's an equal sign. Equals negative. Equals 18. We add them, so we get 105x equals 525. So we get x equals 5. And then we go through and get y equals -3. I'm not going to do it all. Right? So this is, the numbers are bigger, but you're going to get the same answer. So this one's trickier, but it's still doable. So the whole point of like learning these different systems, right? You did graphing, substitution, and now you have elimination. It's pretty much like whatever one's quicker. So if you saw something like this where they're already, or no, if you saw something like this where they're already opposites, you want to be like, elimination is the quickest way to do it. But if you have a favorite, you can do that. So the whole point of this is to just find, use which tool in the toolbox is your favorite, which one's the most applicable. Like if you're in a sport, like if you're playing basketball, not every point you make is going to be a layup. Sometimes you make points with free throws, sometimes you make 3-pointers. You have different plays for different strategies. So that's like our solving systems, right? We're trying to figure out which x and which y will make these both true, and there's lots of different ways to do it.